Now let's see how you can show that the product of the half angle formula is R. Okay, so it says that we have to prove that this left hand side R1 is equal to this right hand side, which is 4R into sine alpha by 2, cos beta by 2, cos gamma by 2. We have to prove this. So obviously it's easier going from a larger expression to a smaller expression. So we take the right hand side and let's see how it eventually converts into the left hand expression, which is R1. So 4R into these trigonometric functions. Now you can write down 4R as this. 4 into R is basically the product of the three sides over 4 into the area of the triangle, okay, that these three sides make, into sine alpha by 2 using the half angle formula can be written like this, right? S minus B into S minus C over BC, right? Because you take the two sides, S minus the first side that is not the opposite side of alpha. So basically let me just draw this out again. Okay, let's say this is the angle alpha, so the opposite side would be A, and these are the two sides at B and C. So the two sides that make up the angle alpha are B and C. So you use those two in the sine expression, right? S minus the first side that makes up the angle alpha into S minus the second side that makes up the angle alpha over the product of those two sides into cos beta by 2. Now for cos it's different, the half angle formula, right? It is S into S minus B over AC. Now since this was the side B, so this is the angle beta, right? And this is the side C, so this is the angle gamma, right? Now you can clearly see that cos beta by 2, so the cos of this angle over here is the cos of the half of this angle is equal to S into S minus B. B is the opposite side to the angle beta over AC. A and C are the sides that make up the angle beta, right? So S into S minus the side that is opposite to angle beta over the two sides that make up the angle beta. Similarly for cos gamma by 2, S into S minus the side that is opposite to angle gamma, the side opposite to angle gamma is C, over the two sides that make up the angle gamma, which are A and B, right? Now that you have all of this, you can cancel out this 4 with this 4 and you're left with this expression, right? You multiply all three of these to get this expression. Now you can cancel out this under root sign with this square, this square, this square, this square, this square, and this square, right? So you get this. Now you can cancel out this ABC with this ABC, and you're eventually left with this expression, right? And you multiply this expression with S minus A into S minus A. Why? Because S minus A is missing from this numerator, right? We need to use the Heron's formula now. So you need S minus A. But since you're multiplying the numerator with S minus A, you need to multiply the denominator with S minus A as well, because the entire value of whatever you're multiplying with has to be equal to 1, right? So the actual expression does not change in value. So now that you have this, once you apply the Heron's formula on this numerator, if you remember, the Heron's formula states that the area of the triangle is equal to under root S into S minus A into S minus B into S minus C, right? So basically this numerator is equal to the area of the triangle whole square, right? So you have this expression. Now obviously you can cancel out one of these with this triangle in the denominator, this area in the denominator. So you have this expression now, and that is equal to R1, the area, over S minus one of the sides, that is R1.